Hello friends, this is Alex presenting you how to prepare integral calculus. Many students feel integral calculus is very difficult, but actually it is not true. If you learn the concept systematically one after the other, then you can easily do all the problems. Now we will discuss about what are the types of integration present. As a first type, the integration is nothing but the inverse process of differentiation. What do you mean by inverse process of differentiation? We have a list of formulas for the differentiation. That is the differentiation of sin x is cos x. If you integrate cos x, you will get back the sin x. This is the inverse process of the differentiation. Now let's see what are the formulas are there, because these are the basic formulas. If you know these formulas, then you can do all the problems easily. See, this is the first formula, integration of x power n. Integration of x power n is x power n plus 1 by n plus 1. Suppose if I want to integrate x power 5, then the answer is x power 6 by 6. Then you see this one, this is a differentiation list we have. Differentiation of sin x is cos x. So if I integrate cos x, I will get sin x. In the same way, the differentiation of cos x is minus sin x. Okay, so if I take differentiation of minus cos x, it is sin x. So the reverse process, the integration of sin x is minus cos x. So in this way, we will slowly see all the formulas. We will memorize now so that we can use it later. See, the differentiation of tan x is secant square x. So the integration of secant square x is tan x plus c. Then the differentiation of cot x is minus cosecant square x. So we took minus cot x, so it is cosecant square x. So when that is the case, integration of cosecant square x is minus cot x. So you can also keep memorizing now. Then the differentiation of secant x is secant x tan x. So the reverse process, which is the integration of secant x tan x, is secant x. Then comes the integration of cosecant x cot x is minus cosecant x. Then comes the differentiation of sin inverse x is 1 by root 1 minus x square. So the integration of dx by root 1 minus x square is sin inverse x. Then the next formula we won't be using much because it is just a minus. Then the another one is differentiation of tan inverse x, which is 1 by 1 plus x square. So integration of 1 by 1 plus x square is tan inverse x. Then again cot inverse is similar to the tan inverse. Then differentiation of secant inverse x is 1 by x root x square minus 1. So the integration of dx by x root x square minus 1 is secant inverse x plus c. Then cosecant inverse is similar to it. Then differentiation of e power x is e power x. So integration of e power x is e power x plus c. Then differentiation of log x is 1 by x. So the integration of 1 by x is log x plus c. Then the last one, differentiation of a power x is a power x into log a. But here the formula is altered. So the integration of a power x is a power x by log a plus c. So these are the basic integration formulas which use in all the problem. But here we see it as a special type, that is inverse process differentiation, as a type 1, because these formulas can be applied directly. I'll show you few problems now and few problems I'll solve and show you. So few things we'll discuss. See, if you want to integrate cos 2x, just to look at this formula, cos x dx. So the integration is sin x. So this will become sin 2x. Since the coefficient of x is 2, we have to divide by 2. So it will be sin 2x by 2 plus c. This is how the formula works. Let's discuss some more examples. To see this problem, we have to integrate x cube minus 1 by x square. See, if you individually divide, you will be getting integration of x. First term will become x and then it will be minus 1 by x square. And this minus 1 by x square you can carry up as x power minus 2. Then after that, use this formula, that is x power n. So this is x power 1. So what will happen if I integrate x square by 2? Okay. Then the second one, x power minus 2 is there. So x power minus 2 plus 1 by minus 2 plus 1. So finally the answer is x square by 2 plus 1 by x. And we can put plus c at the end. Instead of putting separately plus c1 and c2, we can directly put plus c. Okay. Now see the next one. This is once again x power n formula. If you apply this formula, we have to put plus 1 in the power. So x power 2 by 3 plus 1 by 2 by 3 plus 1. So totally it will become 5 by 3. So x power 5 by 3 by 5 by 3. That by 5 by 3 is written as 3 by 5. Then the remaining term integration plus c. And look at the next one. X power 3 by 2 plus 2 e power x minus 1 by x. See, for the first one, again first term use this formula, adding plus 1 to the power. So that will become x power 3 by 2 plus 1 by 3 by 2 plus 1. Okay. Then integration of e power x. E power x already we listed here. So integration of e power x only. And 2 is there, which will keep it outside. Then integration of 1 by x. 1 by x we have it here, which is log x. And there is a minus sign. So minus log x plus c. This is how the integration problem we do. We just use a basic formula. When this basic method is not applicable, we go for the different types of problem that we see in the next part. Now let's see some more examples. See, integration of sin x plus cos x. So directly applying this formula will be your first term, then applying this formula will be your second term. That's all. Then coming to the next one, this is little different because we don't have any term like this here to integrate. But if you multiply inside, what will happen? I will get cosecant square x. Then I can use this formula. Okay. Then the second term will become cosecant x into cot x. For that I can use this formula. So it's very easy. So in the previous problem we applied directly all the formulas, but here we do some multiplication or some rearrangement. Then we will continue. Now take for example this one. Again we don't have any term like this here to integrate. So I have to divide individually. If I divide individually, what will happen? 1 by cos square x minus sin x by cos square x. Then 1 by cos square x is secant square x, which we have a formula here, which is secant square x dx. Then sin x by cos square x. Sin x by cos x is tan. One more cos is remaining, that will go up as secant x. So tan x secant x, again we have a formula. Okay. Then we'll see some more problem from the exercise. See, all this thing we can use the same concept, that is the same basic formula, which is the inverse process differentiation and complete. For example, I will take this one. Just to multiply x square inside, what will happen? First term will become x square and second term will become minus 1. Then apply the formula. Then this whole square expansion we have to give. Okay, root x minus 1 by root x whole square is x plus 1 by x, then minus 2. Then individually you integrate. Then this individually you divide. This also individually you divide by root x, alter the power, then apply the first formula, x power n formula. Then this one you can factorize the numerator. Okay. This I will do and show you here. If I take x square from the first two term, what will happen? X square into x minus 1. Then the last two term I will keep it separately. Okay. Then whole divided by x minus 1. So I will individually divide the first term by x minus 1. This also by x minus 1. So what will happen? We can cancel this and this. So I am left with only x square plus 1 dx. Now I can apply the formula. This will become x cube by 3 plus integration of 1 is x plus c. That's all. So certain things we have to do some rearrangement, then we have to integrate. See, for example, this also will multiply inside, alter the power and continue. Then this also we can multiply inside, get the term, then use the respective formula. And you see the 19th one, this we have to change into sin and cos. Okay. What is secant square? So secant square is nothing but 1 by cos square. And if I write 1 by cos square x here, then cosecant square is 1 by sin square. If I alter, that sin square will go up like this. Basically I have integration of tan square x, but we don't have any formula called integration of tan square x in this list. But I can use this one. Using the identity, convert the tan square x as secant square x minus 1. Then secant square x is tan x, then minus 1 is minus x plus c. So we can finish the problem. So this is what the type 1, which is the inverse process of differentiation. Now let's continue with the type 2. Type 2 is nothing but integration by substitution. So if you want to integrate some term, we use substitution, then we use the basic formula. So I'll show you some of the problems here. See, for example, if you want to integrate this, in our basic formula list, we have the integration of sin x, but we did not have any term like sin of x square plus 1 and 1 2x also outside. But here, if you give some substitution, then this term will reduce to the basic formula. So what I will do is I will take the inner function as t. Suppose if I take x square plus 1 as t, what will be your dt? It is going to be 2x dx. I will work out and show here. Suppose if I take t equal to x square plus 1, then dt will become 2x dx. See, when I want to integrate 2x sine of x square plus 1 into dx, this entire term is nothing but dt. Okay, then this is nothing but t. So I have to put sin t. See, I told this term was not there in that formula list, but this term was there. So integration of sin is what? Minus cos t plus c. After integration, we will replace the t. So now onwards, you should see how to take t and get dt, which is present in the question. So this is minus cos of x square plus c. Okay. Now I'll show you some more problem here. See, the previous one which we solved is minus cos of x square plus 1 plus c. For example, you take this problem, this fourth one. See, the inner function is tan inverse x. If you take t as tan inverse x, what will happen? dt will become 1 by 1 plus x square. So integration of sine of tan inverse x by 1 plus x square we have, okay, into dx. I'll take t is equal to tan inverse x. So what will happen to dt? 1 by 1 plus x square. Okay, so this dx by 1 plus x square is totally dt. So when I replace, it will become sin t dt. Once again the same formula, which is minus cos t plus c, but this time our t is tan inverse x. Okay, so what is not possible directly, we'll give substitution, bring it to the basic formula method, then we apply the integration formula. So this is how all these problems work. But here we have additionally 4 more formulas which you have to memorize, which is not there in the type 1. Okay, first we will list all the formulas, then we will see some more problem how to use t and dt to integrate the given problem. So the 4 formulas which we derive using the method of substitution is, first one is integration of tan x, memorize now, which is log of secant x plus c. Then number 2, integration of cot x, which is log of sin x. Tan x is log of secant x plus c, cot x is log of sin x plus c. Then the third one, integration of secant x, which is log of secant x plus tan x. Then the fourth one, integration of cosecant x, which is log of cosecant x minus cot x. So these formulas also, along with the basic formula list, we will study. Now we will see how substitutions can be made for every problem. Okay. See, we have integration of sin cube x into cos square x. So what I can do is, this sin cube can be split into sin square into sin x, because I will use this as dt. So t should be cos x. So when t is cos x, dt will be minus sin x. So this will become minus dt, and this will become t square, and this will become t square, cos square x is t square, and sin square x can be changed into 1 minus cos square x, so it will become 1 minus t square. Then after that you will get something like this. After multiplication you will get back the basic term, then we can use the integration formula, x power n formula. Then after integration, we can replace the t value. Okay, so I'm telling you the method. You have to solve and see, then you confirm the answer, then you move to the next. Then see the next one. This is also important for the examination point of view. Integration of sin x by sin x plus a. I'll take the inner function as t. Then x will be from this t minus a, that I'll replace in the numerator x. Then after that, expand using the sin a minus b formula, individually divide. Okay, after division, this cos a is a constant, we can take it out. So integration of dt is only t, and integration of cot x, which we discussed here, log of sin x. So substitute, then replace the t. And this one is little tricky problem where we have to do some alteration because direct substitution won't work. So this one, as usual, tan can be replaced as sin and cos, then take LCM, we'll get like this. Okay, but if you take something as t, dt should be there. It won't come because if we take this as t, the denominator as t, then dt won't come. So for that, I have to put 1 by 2 outside. To compensate that, since this is cos x, I have to put cos x plus cos x. Okay, along with that, I have to put plus sin x and minus sin x. So this alteration I have done because I will divide this first two term alone by denominator, then the next two term alone by denominator. After that, we'll get something like this. Now this works t dt method. If I take this as t, this numerator will become dt. It will become log t, then replace all the t. So learn this method, which is very important. Now I will show you I'll discuss you the direct substitution problem. One or two tricky problem, I'll tell you the method, and I will work out and show here. See, from this, what should be t? 1 plus x square. So dt will be 2x. So integral dt by t. Okay, here log x should be t because this 1 by x is here. Okay, so it will become dt. So it will become t square dt, then I can integrate. From this, you have to take x common out. After taking x common, I'll show here. After taking x, it will become like this. Okay. Now if I take t is equal to 1 plus log x, then dt will become 1 by x dx. So this dx by x will become dt. So integral dt by t. So I can complete the problem, which is log t, and replace the t. Okay. Then next one, question number 4. Here I can take t as cos x because this is an inner function. Always take the inner function as t. Here I can take anything as t, but I can take this as t. So dt will become cos ax plus b into a. Then I can substitute and integrate. Here I can take this ax plus b as t. Here I can take x plus 2 as t. So all these things you can continue. So here the inner function is t. In this problem, you have to take root x common, then you have to continue like this. Okay, and this is one little tricky problem. I'll show you the method here. See, inner function, what is the inner function? X cube minus 1, that we will take it as t. So when you take x cube minus 1 as t, 3x square dx will be dt. Okay, now the question, I have to alter it as x cube minus 1 whole power 1 by 3. This x power 5 should be written as x cube into x square dx because this is t power 1 by 3. Now this x cube I have to take from here, which is t plus 1. Okay, then x square dx is nothing but from here, which is dt by 3. Then after that I can multiply inside, then apply the basic formula. Okay, in this way we can continue the other problems. Here the entire denominator is t, so we'll get numerator as dt by 2. Then it will become log t, half log t. This tan inverse x is t, but this is tricky. This 19th one. For this we have to use the 20th problem concept. I'll show you how. See this problem, integral e power 2x minus 1 by e power 2x plus 1 dx. See, when I take the denominator as t, what will happen? Dt will become e power 2x into 2 dx, but I cannot replace here because I have e power 2x minus 1. So this entire approach itself not correct because it is not working, this substitution. So for this I have to divide numerator and denominator by e power x. So the first term will become e power x and the second will become e power minus x because I am dividing individually. Okay. Then after that, if you take the entire denominator as t, this term will become dt. Then you can continue. Okay. Then the other problems you can do by usual method. This is cos square x. You take it to the numerator, so it becomes secant square x by 1 minus tan x whole square. Take 1 minus tan x as t and continue. Here root x is t. Here inside the root term, that is sin 2x is t. Here inside the root term 1 plus sin x is t. Here if I take log x as t, differentiation of log x is what, 1 by sin x into cos x using the chain rule. So it will become cot x, this will become dt. Okay, so this is another usual method. Here inside the square, that is 1 plus cos x is t. And this problem and this problem is similar to the one which I showed you, like we have to do some alteration before the substitution I told this. So what is the type of alteration we have done? We have to give there also. Okay. Then comes another tricky problem. This 34. This I will show you. But this is all usual method. Okay. So you have to work out and check the answer. Now coming to this question number 34. Here if you do any method, it won't come. So there is only one particular way of doing it. So please remember, otherwise you should not waste time in the exam. See here I have to divide the numerator and denominator by cos square x. So numerator will become root tan x into secant square x whole divided by here sin x cos x whole divided by cos square x. So cos x and cos square will get cancelled. This will become tan. And numerator we have root tan. So if I cancel, I will be left with only this much. Okay. Then if I take it as t as root tan x, when denominator has root, I can take t along with the root. So dt will become 1 by 2 root tan x into secant square x dx. So I got the entire term except for the 2. So this 2 I will carry here. This entire term is 2 dt. So integral 2 dt is nothing but 2t plus c. And if I replace the t, it will become 2 root tan x plus c. Apart from this, all the other problem can be easily done. You take the denominator as t, you will get the numerator. Here, the numerator should be replaced as, this is 1 right in the numerator. So replace it as sin square x plus cos square x, individually divide. Then you will get the answer. So with this, type 2 is over. Now comes the third type, that is integration using trigonometric identities. So for using trigonometric identities, that is trigonometric formulas, you should be very clear with all the formula. Then only you will know what formula to use when. Okay, I will show you a few problems here. See, you take this one, 1 minus cos x by 1 plus cos x. If you don't know what is the formula for this, then we cannot use this type. So memorizing the formula is like very important in this particular topic. See here, integration 1 minus cos x is 2 sin square x by 2 by 2 cos square x by 2, because 1 plus cos x is 2 cos square x by 2. Cancel 2 and 2, it will become tan square x by 2. As I already told you, we cannot integrate the tan square. We have to change into secant square x by 2 minus 1 using the identity formula. Then this become a basic formula, tan x by 2. Since the coefficient is half, I have to divide by half. Okay, that will become 2 here minus x plus c. See, if you know formula, it is very easy. I will show you one more from this list. This one. See, integration of cos 2x plus 2 sin square x by cos square x. It appears to be very complicated, but we have 4 formulas for cos 2x. In terms of tan, then the other 3 formulas, but I will apply one particular formula. This is nothing but 1 minus 2 sin square x. Okay, so what will happen if I apply this formula? This will get cut. I will be left with only this much. Then after that, it's easy. It becomes secant square x. That integration I can complete because that is a basic formula. So in this way, the formulas are like very important trigonometric formulas. I'll show you one more. This one. Since the denominator is having sine and cos, I am going to apply cos 2x, the another formula which is having sine and cos term. Cos square x minus sine square x. Okay. Then this is cos x plus sine x whole square. Now numerator is of the form a plus b into a minus b. So I can cancel one term with the denominator. That's all. After that it is t dt method. I'll take this as t. I'll get this as dt. Sometime dt or minus dt, whatever. But it will become dt by t log t. I can complete the problem. This one I have to individually divide and do. Okay. This one I can write the numerator as 1 minus cos square x, that is 1 plus cos x into 1 minus cos x, using all formulas. Then I can write the denominator, so it will get cancelled. Then I can integrate. See this one. This will have a different formula, that is 2 cos square x minus 1 I have to use, because the denominator is also having a cos term. So it is easy if I use this formula. So 2 cos square alpha minus 1 whole divided by cos x minus cos alpha. Okay. Then after removing the bracket, this 1 will get cut. Then you can take the 2 common. Then cos square x minus cos square alpha, you can go for this type of method, a plus b into a minus b. Okay. Cancel one term with the denominator, then rest of the term you can integrate. So this is how the formulas work. But these formulas for these type of problem also very important, like converting the product to sum or difference. I'll show you this problem, and after that I'll show you this problem. That's all. With that, this topic is over. See the question. I'll write this in the reverse order. So sine 3x, sine 2x, sine x dx. Now take these two, apply the formula. I'll show you the formula here. Sin x into sin y, which is nothing but minus half cos of x plus y minus cos of x minus y. Okay, when both are sine, it will come minus half into cos of adding both and minus cos of subtracting both. So if I apply this, what will happen? Minus 1 by 2 open bracket cos of add both the angle minus cos of subtract both the angle, then outside there is a sin x dx. Now multiply sin x with both the term. So minus half I can take outside. When I multiply, I will be getting cos phi x sin x minus cos x sin x dx. Again we have a different formula for this. So minus half, again 1 by 2 sin of add both minus sin of subtract both. This is sin 2x formula. So half sin 2x. That's why you should be very good in trigonometric formula, so that we know what to apply when. Again I can take the 1 by 4 out. I mean 1 by 2 out. So outside already 1 by 2 is there, so it becomes 1 by 4. So now I have sin 6x, sin 4x minus sin 2x dx. Then this becomes the type 1. We can integrate, and we can multiply this minus 1 by 4 inside. This is how this question also can be done. So for that, first list out all the formulas, memorize it thoroughly. Coming to the next one, this problem needs little bit rearrangement. The rearrangement is, we will take integral sign. In the numerator, we will put sin a minus b, and the denominator we will write it as it is. Then since sin a minus b is a constant, outside I can divide by sin a minus b. Okay, this rearrangement we should remember. Then after this a minus b should be written in terms of x minus a and x minus b. That can be done when x minus a, I'll write it here, That is a minus b is nothing but x minus b minus x minus a. So what will happen? If I simplify this, I'll get a minus b. So this numerator a minus b can be replaced with this. So outside 1 by sine a minus b as it is, integral sine of x minus b minus x minus a whole divided by denominator I will write as it is, cos of x minus a cos of x minus b. Now this is of the form sine a minus b, so we can expand. So 1 by sine a minus b outside. If I expand the numerator, it is sine a cos b minus cos a sin b. This is x minus b, x minus a. So sin a cos b minus cos a sin b whole divided by cos of x minus a into cos of x minus b. Then after that I have to divide individually. I'll show you here. Next comes the other form where you will be having a linear term outside the quadratic term. Here we have a procedure. If you follow that, you will get the answer easily. This procedure somewhat similar to what we discussed already, but here the outside term we have to write it as px plus q is equal to capital A into differentiation of the term what is inside the root plus b. Then after finding a and b, replace this px plus q in the question with this term. So it is going to be a into 2ax plus b into the quadratic term which is inside the root. After that, split into two parts. This entire root you multiply the first term, then the entire root with the second term. So a is constant which can be taken out. So we get something like this. This is the first integration plus b into root of ax square plus bx plus c. That's all. We got the known type. This is type 2 where we take this as t. This will become dt. So this will become root t dt. We can finish the integration. It is type 2. This is the last type which we discussed. After doing the completing square, any one of the previous formula will come. Then we can complete. That is using the 3 more special integrals. So by seeing the problem, if you identify the method, then it is very easy to complete. Next comes the type 4, which is integrals of some particular functions. Here we have 6 formulas which we have to memorize. I list all the 6 formulas here. Number 1, integral dx by x square minus a square is 1 by 2a log of x minus a by x plus a. Then the other formula is number 2, which is a square minus x square in the denominator, which is 1 by 2a log of a plus x by a minus x. Then the third one, integral dx by x square plus a square, which is 1 by a tan inverse x by a. Then integral dx by root of x square minus a square, which is log of mod x plus root of x square plus minus a square. Then this is root of a square minus x square, which we have integral dx by root of a square minus x square is sin inverse x by a. Then we have integral dx by root of x square plus a square, which is log of mod x plus root of x square plus a square. So these are the 6 formulas which comes under the integral of some particular function. Here I'll show you how to use these formulas. Suppose if a number present instead of a, you take this as a square form, that is 4 square. So now you know a is 4. Then x square minus a square, it is matching with this formula. So substitute the value of a, that's all. But instead of that, if you have a quadratic equation here, you should know how to do the completing square. So I'll teach you completing square for few problems. Then after that we can apply the formula directly here. Okay, I'll show you how to do completing square for this. When you have x square minus 6x plus 13. Look at this term. We have x square minus 6x plus 13, isn't it? Take half of this number, which is nothing but minus 3. Its square is what? 9. So you have to add that square and subtract that square and write the last term as it is. This is the procedure. Now this whole thing will become x minus 3 whole square, then these two will become plus 4, which is 2 square. Then I can apply that 6 formulas which we were discussing. That will become dx by x minus 3 whole square plus 2 square is x square plus a square, which is 1 by a tan inverse x by a plus c. Okay, I'll show you another problem how to do the completing square when is having a coefficient 3 for the x square. We have 3 x square plus 13x minus 10. Take 3 out, so it will become x square plus 13x by 3 minus 10 by 3. Now what is half of this number? We have to divide by 2, so 13 by 6. What is square of this number? 169 by 36. So this term we have to add and subtract. So we have x square plus 13x by 3 plus 169 by 36 minus 169 by 36. Always add first, okay, because this entire thing will become a plus b whole square form. So which is nothing but x plus 13 by 6 whole square. Okay, when you do 2ab term, what will happen? 2x into 13 by 6, so it will become 13 by 3, which is present here. Then this I have to multiply into 12 into 12 so that I can make the common denominator, that is 36. Then this will become minus 289. Okay, that will become 17 by 6 whole square. So finally we will be having 1 by 3 integral dx by x plus 13 by 6 whole square minus 17 by 6 whole square. After that we can apply the formula and continue the problem. So in this way, the completing square you practice well for all the term given in this exercise, so that you can apply this method. After completing square, just applying the formula. So memorize the formula. So you can see all the problem here. So in this problem, you can find numerator will not have anything, only dx will be there. But if you have a numerator, some other linear term like this, then we have a different procedure. That is the next type. The general form for this type is integral px plus q, that is numerator is having linear term, denominator is a quadratic ax square plus bx plus c, or we can also have root in the denominator. Okay, for this the procedure is numerator equal to capital A into differentiation of the denominator plus b. This is the procedure, but when I am taking this one, I will take only the term inside the root. So I will show you the problem. We have x plus 2 by 2x square plus 6x plus 5. Okay, as soon as you see the problem, you should know that it is of this form px plus q by ax square plus bx plus c, that is linear by quadratic. So the numerator equal to capital A into differentiation of the denominator plus b. Now I have to find a and b. For that I will take x is equal to 0. I will get one equation. Okay, then I will take x is equal to 1. I will get an equation. I have to solve this to find a and b. After solving this numerator x plus 2 should be replaced with this entire term along with the a and b value. Since I am telling you the procedure, I am not writing the a value. When you are doing it, you have to do and know the method. So I will divide like this with the denominator. Okay, after that I have to individually divide. When I am individually dividing, I can take the a common out. So this is what I will get. Then the second term also b constant. So it will be some numbers which you have to find and use it here, not a and b. See, after that, this is type 2. Because if I take the denominator as t, I will get dt. So I can use type 2, that is integration by substitution. This is completing square. Just now we were discussing. Do the completing square, apply the respective formula. So in this way, we can do the other problems also. See, this is all direct substitution. You can take x cube as t, then after that you will get the formula. So here tan x as t, then you can get the formula. So all these problems can be done in the similar way. With this type is also getting over. When you have factors like this, expand, convert like something like this, then you continue this procedure. So identifying this type is like very important. As soon as you see this question in the exam, you should know this is the type. We have to do numerator equal to capital A into difference of denominator plus b. So with this, using the 6 standard formulas, that is some particular function type is completed. Next type is integration by partial fractions. So integration by partial fractions, we have 3 rules. You should know how to use the rule. If you know the rule, then this method is very simple. Here they have given the 5 rules actually, because this first rule and the third rule are same. I'll take this as the first rule, that is when you have 3 different factors. Okay, what I will do is I will do a by the first factor plus b by the second factor plus c by the third factor. Then the next rule is I have repeated factor. Repeated factor means this x minus a is repeated twice. That's why it is put whole square. For this, I cannot use the first rule. It is a repeated factor. So I have to use a repeated factor rule, which is a by the first factor, that is x minus a plus b by x minus a whole square. Then the last one is similar to the first rule. So don't miss the rule and be careful when applying this in the problem. Then the last one is when you have a non-factorizable quadratic equation, this rule comes. That is, in the numerator there will be bx plus c instead of the constant alone. So these are the rules. I'll show you how to use the rule. See, very simple. You take this problem, 2 factors are there. Use the first rule, that is a by first factor, b by second factor. Then after that you cross multiply and find a and b. After finding a and b, substitute here and integrate here. That's all. When this step comes, it is somewhat similar to the type 1, which is a basic formula. When you have 1 by x, it is log x. So 1 by x plus 1 is log x plus 1. Okay. Then coming to this I will tell you in the later part, because now I want to tell all the rules. Okay. Now see this one. This is a repeated rule. So apply the second rule. Okay. Take LCM, find a, b and c. After finding a, b and c, you will get something like this. The first term and the last term are log. The second term is 1 by x square, which is minus 1 by x. So it is a different formula. Substitute and we will get the answer. Then third one is non-factorizable quadratic equation. When you have x square plus 1, it is a non-factorizable. So apply the third rule. Then after the taking LCM, finding a, b and c, then integrate and you will be getting like this. The first one is log, but second one is the type 2, which is substitution. You take the denominator as t, then the numerator will become dt. So dt by t, so log t. Then this one is that 6 formulas which we were discussing, dx by x square plus a square, which is 1 by a tan inverse x by a. So these are the basic rules. Now we will see some other problem, how all these rules are applied. This is once again the first rule. This one we have to factorize as x plus 3 into x minus 3. Apply the first rule. This is again first rule with 3 factors are there, all are different. This also 3 factors are there, all are different. So apply the first rule. This we have to factorize as x plus 1 into x plus 2. Then again apply the first rule. Okay. And this one you compare with this problem. Do you see the degrees of numerator and denominator are same? Both are x square. So you cannot apply the rule because it is not a proper rational function. Proper rational function means the numerator degree should be less than the denominator degree, and this can be applied, this partial fraction rules can be applied only for the proper rational function. Okay. If it is improper, we have to do long division, reduce it to the proper rational function, then apply the rule. If you miss this, then the entire problem is wrong. See, you have like this, you do the long division. After doing long division, it will become like this. That is quotient plus remainder by divisor. then the denominator is factorized like this, then they have integrated this alone separately because the first part is anyway x, that they have done it here. This usual method, the first rule, a by first factor, then b by second factor. So we have to carefully see whether it is a proper rational function or not. Then you apply. If it is not there, then you do the long division. So this problem, do you see the degrees are same? This is also x square. Denominator, if you multiply this x with this, that is also x square. So you have to do long division, then write into q plus r by d form, then go for integration. That is applying the partial fraction rule. This is bx plus c rule. This is the second rule, repeated factor. This one you have to factorize and apply the proper rule. This factorization I will show you here. See, you have x square common in the first two term, then minus common in the next two term. Then x minus 1 itself common, it will become x square minus 1. Okay. Then x minus 1, this can be written as x plus 1 into x minus 1. So I can write this as x minus 1 whole square into x plus 1. Then you have to apply the second rule. Okay. And for one problem, I'll show you the long division also. See here. Since the numerator degree is more, we have to do the long division. If it is equal also, we have to do the long division. So you write the numerator. Okay. Write the denominator. X time will become x cube, then minus x. Then you have to subtract. When subtraction, you have to change the sign. This will get cancelled. It will become 2x plus 1. Okay. Now the degree is smaller. Then this is quotient, remainder, divisor. So you have to write q plus r by d form, q plus r by d. Then after that integrate separately. This is nothing but x square by 2. This you have to factorize and x plus 1 into x minus 1. Then apply the first rule, which is a by first factor plus b by second factor. So these are the rules we have. But there are some problem where we have to do some rearrangement. Then we have to come for the rule. Those we will see now. Now look at the problem. See, you have this. If you apply the non-factorable quadratic rule, what will happen? It will become very complicated. That is, I have to apply ax plus b by the first factor plus cx plus d by second factor. Then I have a, b, c, d I have to find, then I have to integrate. But instead of this, if you take a simple substitution t as x square, then dt will become 2x. Then the term itself reduces to simple term t plus 1 into t plus 3. Then I can apply the first rule. Apply the first rule, then finish integration, then replace the t as x square. But there are other problem where you will not have dt. For example, you see this one. See. Here I can use only t as x square. I cannot use dt. Then what will happen? I will get t by t plus 1 into t plus 4. We can apply the partial fraction rule, but I cannot integrate with t itself because I will be getting a value as something divided by t plus 1, but still I will be having dx here for the first term. Then I will be having dx by x square plus 4. Sorry, t plus 4. Since it is dx and t, I cannot integrate. So before integration itself, replace this. Then after that, I have to apply the that 6 formulas. One formula will come here. So here we replace the t before the integration. But in the previous case, since we use dt, we replace it after integration. So this difference you should know. Then combining these both, we have one more problem where you have x square everywhere. So replace it with t. But what will happen if I replace t here and here? If you multiply, it will become t square. Even denominator is also t square. So what did I tell? If the degree is same or more, we have to do the long division. Then we have to continue. This is like more complicated than the other thing. And even here you can go for substitution. You can take x power 4 as t. I'll show you here. If you see the usual method, factorizing the denominator, what will happen? This will become x power 4 minus 1 is x square plus 1 into x square minus 1. Okay, then again if I factorize this, I will be getting x into x square plus 1. This will be x plus 1 into x minus 1. So if I apply the rule, it will become like more complicated because I will get too many uh, variables like a, b, c like that. So it's difficult to find everything. Instead, if you take t as x power 4, then what will happen to dt? 4x cube dx. So I purposely am going to multiply x cube with both numerator and denominator. Okay. Now this will become x power 4. This will become dt by 4. So 1 by 4 into dt by t into t plus 1. Now I can go for partial fraction. So you should give the smart substitution so that making the problem easier. Instead of doing a very big procedure, we can do it in a simple way. And one more thing, if this is t, then numerator will become minus dt and continue. And even this also similar. See, why we multiplied x power 3 both numerator and denominator here in this problem? Because one power less than what is given in the question, that is x power 4. So here it is x power n. So I have to multiply with x power n minus 1 both numerator and denominator. Take t and dt, you will get similar step. See, even here you can split this as x square, like this we can split. Okay, I'll show you this problem. So you can split the problem like this. Integral dx by x square plus 1 into x square minus 1. So I can go for taking t is equal to x square, but I am not using dt because there is no dt here. So integral dx by t plus 1 into t plus 2. This substitution is only t plus 1 into t minus 1. This substitution only for doing the partial fraction. After finding a and b, when you want to integrate, still dx is here. So we will replace this as x square, then we will continue. This we discussed already. And there is one more big problem. With that, this topic is also getting over. See here, everything is given in terms of the trigonometric function. See, we have one cos phi separately, right? So that is going to become dt. So definitely sin phi should be t. So you change this as 1 minus sin square phi. Okay. Then after that, we can give dt and rearrange, you will get linear by quadratic form. Then we can continue the usual procedure. Here they do the factorization, then they apply the second rule. Then after finishing the integration, finally replace all the substitutions. It will come in terms of sin phi. So with this, partial fraction is also over. So you can practice and check the answers. Next method is integration by parts. So integration by parts, you will be having two different functions. You should know how to choose which is u and which is dv. I'll show you here. So the formula is integral u dv equal to uv minus integral v du. Suppose if a question has two terms, first choose which is u and dv. I will show you some problem from the exercise. I will take this one. So take the question, integral x sine 3x dx. Okay. Now write I late. I stands for inverse trig, L for log, A for algebraic, T for trigonometric, E for exponent. Here we have algebraic and trigonometric. So put a tick. So what comes first in the order of I late is u and the next is the dv. So from this we know u is equal to x and dv equal to sine 3x. From u I can differentiate and get du, that is dx. From v I have to integrate and get v, that is nothing but minus cos 3x by 3. Now substitute everything in this formula. So u v minus integral v du. That's all. Now this becomes minus x cos 3x by 3 plus 1 by 3 integral cos 3x dx. Now this become the type 1. We can apply the formula and complete the problem. So the first term as it is plus 1 by 3, this will become sin 3x by 3. Already 3 is there, so I can make it as 9 plus c. This is how integration by parts work. Here you can notice one thing, this will be made up of two different functions, product of two different functions ranging from inverse trig to exponential. Then we go for this method. Now I will discuss with you some more problem how to take u and dv. You take this one, you have integral x square e power x. So this is dv and this is u according to the order of highlight. So from this du will be 2x and v will be e power x. Now the formula is uv minus integral v du, isn't it? So u v minus integral v du. Now once again I have to do highlight for this. So this is how the concept is applied for the problems. So when you have a simple term, you can integrate as it is, but if you have a product of two different function, again we go for a highlight method. So again this will become dv and this will become u, and we'll continue the process once again and complete the problem. Now here log comes first, so it is according to the order of highlight, log and algebraic. So accordingly you choose the function and continue. And here inverse trig comes first. So this is u and the other is dv. Now take this problem. This is having some term. First we have to give substitution, like t is equal to cos inverse x. So dt will become minus 1 by root 1 minus x square dx. Then when t is cos inverse x, from this cos t is x. If I replace everything in the question, cos t, that is x is cos t into cos inverse x is t into 1 by root of 1 minus x square is minus dt. So I will put minus here and dt here. Now I have to do highlight for this. Here t is treated as algebraic. So in highlight method, algebraic and trigonometric is there. Accordingly you take the substitution, find du and v, then substitute in the uv minus integral v du and complete the problem, and finally replace the t. When you have a single function like this or log x, one function u will be taken as tan inverse x, but another one is dx. See, when you have integral tan inverse x dx, this is u and this is dv. Okay, then you can do the problem. So in this way the rest of the problems of this type can be completed. Next comes a special form which is based on the integration by parts. That is, when you have e power x into f of x plus f dash of x, then the answer is e power x into f of x. For example, if you see this problem, we have exactly like this. See, instead of f of x we have tan inverse x, and f dash of x we have 1 plus 1 by x square. If this is f of x, its differentiation is 1 by 1 plus x square, isn't it? Then finally the answer can be written as e power x into tan inverse x plus c by specifying this form. Okay, so when you have e power x with something, first we have to check whether this form is applicable or not. I'll show you the other problems. See, in this problem f of x is cos x, sin x, f dash of x is cos x. So it's easy. Here f of x is 1 by x, f dash of x is minus 1 by x square. But you can see these problems, this form is not visible. So we have to do some rearrangement and bring into this form. Even this problem, we can't see what is f of x and f dash of x without doing some rearrangement. I'll show you the rearrangement here. In this problem, with the numerator put minus 1 plus 1, and already there is one more 1, and the denominator you copy as it is into e power x dx. The purpose is to take these two terms together and divide by the denominator, plus 2 by x plus 1 whole square, then we have e power x dx. Now if I factorize this, this will become x plus 1 into x minus 1. So we can cancel one term. The remaining will be e power x into x minus 1 by x plus 1 plus 2 by x plus 1 whole square. If you take this as f of x using u by v method, you will get this as the answer. So the final answer will become e power x f of x plus c. Understood this type? So this rearrangement you should know how to make the rearrangement to get into this form. I will show you another problem. See, this minus 3 we can put minus 1 minus 2, then you can individually divide and continue. Okay, here also with x I can put minus 1 plus 1, then individually I can divide and continue. This one trigonometric formulas we have to apply. I will show you this problem here. To bring into the required form, take 1 plus 2 sin x by 2 cos x by 2 as sin x, and this is 2 cos square x by 2. Now if you individually divide, what will happen to the first term? E power x 1 by 2 into secant square x by 2, plus when you divide individually, this 2 will get cut, then square and this cos x by 2 also will go off, so tan x by 2. Now do you see, this is f of x and this will be f dash of x, so specify that form and give the answer, put plus c. So in this way we can do the other problems like putting minus 1 plus 1. So the rearrangement you should learn. With this special form also completed. Next comes the integral of some more types. We have 3 more formulas. One is integral root of x square minus a square, then root of x square plus a square, then root of a square minus x square. I'll give the formula here. This is the first one. This is, we can call it as 3 more special integral along with that 6 formulas. This is the first one, then this is the second one, and this is the third one. So the problems based on this are very simple. You can do completing square and apply the formula if it is a quadratic equation like this. I already taught you completing square, so follow that method. You will get into any of this form, then apply the formula. That's all. Okay, while doing the completing square, be careful and apply the correct formula. Suppose if it is direct, then only the a value we replace. So with this 3 more special integral problems also getting over. Now let's discuss about some of the miscellaneous problems, its procedure and the basic steps. See, this problem already we discussed in the type 2, that what is inside the root, if you take it as t, then we can easily complete. This is one special problem where you should know the first step, that is we are taking x power 4 common from this term. By taking it common, we will be getting like this. After that we can go for t dt method. So the taking x power 4 from here is the key step in this problem. So if you remember this, we can complete. I'll show one more problem of this type. Let's see, we have any problem in the exercise. Yeah, see, from this if you take x power 4 common, already there is a power 3 by 4. So if you take common, it will come out as x cube. Then this will become 1 by x power 4. After that, what is inside the term, you take it as t, then you can continue with dt. So by seeing itself, you should know the method. That's how the integration will become easier. If you don't know the method, then it is very difficult. Then this one is a partial fraction. Obviously by seeing the denominator, we can identify that too it is having x square plus 1, which is a non-factorable quadratic equation. So it is bx plus c rule. But do you see the numerator is having x power 4, the denominator is only x cube, the degree. So we have to do the long division right into q plus r by d form. Then you continue the partial fraction. Then this problem I will work out and show. We have a easier way to solve this. Here you take t is equal to log x. Okay. But when I want to find dx, it will be better if I have x, right? So if I remove log, the other side will become e power t. E power t is x. So when I differentiate dx, it will become e power t dt. Now replace everything in the question. So log of t plus 1 by t square into e power t dt. Okay. Now split into two integration, that is e power t, this bracket supposed to come here, e power t into log t, this is one integration with dt plus integral e power t into 1 by t square dt. Now we will do highlight for this. This is u, this is dv, u v minus integral v du. I wrote directly. Okay. But if you have a confusion, you have to work out and see. Take separately u, dv, everything, then you do it. Now do you see this form? If I rearrange, that is, if I take e power t common, it will become 1 by t. Then already there is a minus I took common, so minus 1 by t square. This is of the form f of x and f dash of x. So this answer itself, this much only. So I finished it. Then after that, you have to replace all the t. This will become log of log x and e power t is what? X. So put that x front minus x by log x plus c. So we finished it in a easier way. So if you know the method, it is very easy to complete the problem. Okay. Consider the next problem, integration of root cot x plus root tan x. We have two procedure, but we'll see one procedure now. You change everything in terms of tan, 1 by root tan x plus root tan x dx. After taking LCM, 1 plus tan x whole divided by root tan x dx we will get. So we will take t is equal to root tan x. What will become dt? 1 by 2 root tan x into secant square x dx. Okay, but the secant square x I have to bring to the other side, that is 2 dt by secant square x will be dx by root tan x. Okay, so this dx by root tan x I am going to replace. Before that, 1 plus tan x, since t is root tan x, if I square, t square is tan x. So 1 plus t square into 2 dt by secant square, right? So that can be written as 1 plus tan square x by identity. If I square this further, I will get t power 4 is tan square x. So this will become t power 4. Now the numerator is t square plus 1 by t power 4 plus 1 dt. Now this is another special form where we have to divide by t square both numerator and denominator. So I will be getting like this. Now we have some procedure for this. Since numerator is having plus, I am going to write this as t minus 1 by t whole square. Because if I expand this, I will get t square plus 1 by t square. Extra I will get minus 2. To cancel that, I have to put plus 2 here. So I will write this as root 2 whole square. Now this term, if I take it as u, this will become du. That's why purposely I am choosing a minus sign here. So this will become du by u square plus root 2 whole square. Now this is of the form 1 by a tan inverse x by a plus c. Replace the u, then replace the t. That's all. So when this form of expression comes, remember that we have to divide by t square both numerator and denominator. Then this also you can do it easily. Take cos square 2x as t and continue. You will get dt by t form. Then apply the 6th standard formula. Now we'll see some of the problems from the exercise. See, this you factorize and apply the partial fraction. This you can do conjugate multiplication. And this you can take substitution x as 1 by t and continue. This already we discussed. Here they gave a hint, taking x as t power 6 is the best substitution, because to avoid the fraction in the power, if x is equal to t power 6, what will happen? This term will become x power half. Okay, but that will become t power 6 whole power half. So it will become t cube. So the entire term will become 1 by t cube plus t square, and from this if I find dx, it is going to be 6t power 5. So 6t power 5 dt. Now take t square common, cancel, then after that if power is higher, do long division and complete the integration and replace the t. This is a partial fraction bx plus c rule. Here you take this as t, then replace the x and expand and individually divide. This one we should know how to rearrange. This is nothing but e power log of x power 5, and e and log will get removed, so this will become only x power 5. In this way, if you rearrange the other term, it is going to become x power 5 minus x power 4 by x power 3 minus x square. Then after that you take out what is common, then you cancel and simplify. Here sin x as t, and you can continue. This one we have to remember the key steps, then only you can do the problem. Now see the rearrangement we are going to make here. I am going to factorize the numerator, that is sin power 8 is there, isn't it? Suppose if it is a power 8 minus b power 8, I can write it as a power 4 plus b power 4. Then a power 4 minus b power 4. Okay, whole divided by, this one can be written as sin square x plus cos square x. Then next term we have 2 times of this, isn't it? I will write it separately as minus sin square x cos square x, again minus sin square x cos square x. The purpose is to combine these two and these two. Numerator, I will keep the first term as it is. Then this I am going to further factorize using the same method, that is sin square x plus cos square x. Then this will become sin square x minus cos square x. Here if I take these two, group it, sin square x if I take common, the remaining will become 1 minus cos square x. In the same way, if I take cos square x common from the first and last term, I will get 1 minus sin square x. This will become sin power 2, because 1 minus cos square x is sin square 2, sin square x, already sin square, totally sin power 4. This will become sin power 4, this will become cos power 4. Entire term I can cut with this. Okay, here for explanation purpose I am doing it directly, but you have to do it in the next step. And this will become 1, and this will become minus cos 2x. This we discussed in the type 3 itself, formula, trigonometric formula. Then after that we can finish the integration, that's all. Then this, similar to the one which we did, we have to introduce sin a minus b in the numerator and 1 by sin a minus b, and denominator as it is. This a minus b you should write now in terms of x plus a and x plus b. So that can be written as x plus a minus of x plus b. Then substitute this entire term here. Then use sin a minus b formula, expand, individually divide, and continue like the problem which we discussed before. And this one is x power 4 is t, you can continue. This is t dt, partial fraction. This is taking t as x square, but we don't use dt. This is similar to the logic e power log sin x is nothing but only sin x, what I told here. Can do the same method here. Here f of a x plus b as t if you take, then this will become t power n, this will become dt by a. Okay, then another tricky problem, this one I will do and show. This denominator sin x plus alpha should be expanded first. So before that I will write sin cube x as it is. This is sin a cos b plus cos a sin b formula I applied. From this you take sin x out. Already this is sin cube, it will become sin power 4. When it has come outside the root, it will become sin square. When it carried to the numerator, it will become cosecant square dx. But this root will be, this is already taken out, so only cos alpha, and here there is no sin x, so we have to divide by sin x, it will become cot x, then sin alpha. Now they take entire denominator as t along with the root, so dt will become 1 by 2 root of cos x plus cot x into sin alpha. Then differentiation of this will be cot x is minus cosecant square x into sin alpha dx. So we can carry this sin alpha and 2 and minus sign to the other side. So minus 2 dt by sine alpha will be the entire term what we need to integrate, cosecant square x dx by root of cos alpha plus cot x sine alpha. So when I want to integrate this, I can integrate this, isn't it? So this is a constant which can be taken out. Integration of dt is only t. So I have to replace the t. The t is nothing but cos alpha plus cot x sine alpha. If you further simplify this as sine by cos, then if you take LCM, we'll get back like this. That can be further written as sine x plus alpha, then plus c. Next comes another difficult problem, but if you apply the formula, it will become easier. We already know in inverse trig, sine inverse x plus cos inverse x is pi by 2, isn't it? So from this, if I take cos inverse x, it is going to be pi by 2 minus sine inverse x. So same thing, everything is in terms of root. So first term I can write as it is. Then for my cos inverse root x, I am going to write pi by 2 minus sine inverse root x, and the entire denominator will become pi by 2. I will take it as 2 by pi into dx. Now this will become 2 times of sine inverse root x, integral sine inverse root x. Then if I split into 2 integration, it is going to become only dx, because pi by 2 and 2 by pi will get cancelled. Now this alone I have to do substitution. I'll take root x is equal to sine theta. So x will become sine square theta. So dx will become 2 sine theta cos theta. Basically it is sine 2 theta d theta, isn't it? So 2 by pi as it is, integral. I have to replace this first. So sine inverse of, integral sign is there, sine inverse of sine theta, which will become theta. Then dx is sine 2 theta d theta. This is nothing but theta into sine 2 theta. We have to do isolate method. Okay, the second part you can complete. This isolate method and substitution alone I will show it here. As I told you, when it is a product of two function, you write isolate and tick the terms algebraic and trigonometric. So this is u, this is dv. If I apply the formula u v, different integration of this will be minus cos 2 theta by 2 minus integral v du. So I have to substitute v here, then du, nothing but d theta. Okay, I am writing it directly, but you have to take separately, then only it will be very clear. Then this integration will become sine 2 theta by 2, and already there is a 2, so I can put by 4. So 2 by pi will become minus theta cos 2 theta by 2 plus 1 by 4 sine 2 theta plus c. Okay, since we have sine theta as root x, try to write everything in terms of sine theta. This in terms of sine theta, this also in terms of sine theta. Then only I can replace that x and get the answer. This theta is nothing but sine inverse root x. Okay, this cos theta, I'll write it here, 1 minus 2 sine square theta. So that if I replace that x, 1 minus 2 x, because sine square theta is x here. Understood? By 2 plus 1 by 4. The sine 2 theta, we have a formula 2 sine theta cos theta, but I want in terms of sine, isn't it? This also I change into root of 1 minus sine square theta. Now everything is in terms of sine square theta, that is sine theta. So this will become 2 root x, root of 1 minus x. Understood? This cos theta I wrote as 1 minus sine square theta. So 1 minus x. Then after simplification, we can rearrange. And there is another part also left. Here I just showed you how to do the integral by parts here. The next problem, you can go for substitution. Root x is equal to cos 2 theta, then find dx, substitute, check whether you are getting isolate. Accordingly you can continue. Then this one, that special form, e power x f of x plus f dash of x, you have to rearrange and continue. Then this one, partial fraction, this total denominator degree is x cube and numerator is x square, so it is already a rational expression. You can apply the partial fraction rule, that is a repeated factors rule. Then in the next one, you can substitute x as cos 2 theta and continue accordingly. In this problem I will show you. Here first term we will take as it is, then log of x square plus 1, using the log rule this 2 will go as a power, so it is log x square whole divided by x power 4. For this x power 4 I will purposely write x and x cube because I want to take this x inside the root. So root of x square plus 1 by x square. Here if I apply the log rule, this is going to be log x plus 1 by x square, then whole divided by x cube dx. Okay, I can individually divide. So root of 1 plus 1 by x square, then log of 1 plus 1 by x square into dx by x cube. Now take t is equal to 1 plus 1 by x square and dt is going to be minus 2 by x cube dx. So dx by x cube is here, that will become dt by minus 2. So minus 2 minus 1 by 2 I will take it out. So it will become root t log t dt. Then accordingly you do udv method, that is isolate, then finally replace the value of t. The entire integration concepts you learnt in less than 90 minutes, but if you want to be more efficient you need a lot of practice. So what are the methods we learnt? Try to apply it for a new problem and try to get the answer. Lot of practice make you more efficient in the integration. If you find the video useful, please subscribe our YouTube channel and like the video and share it to your friends. Thank you and all the best.